Hey everyone, it is me again, Miss Cram. So today we're going to go over the lesson that you did Monday or today, depending on your section. I also just want to give a couple notes of, I read through that last slide, so please make sure that you're filling it out. You gave some really good advice or slides that were giving you a little bit of struggle. I know that there's some frustration. I wish that you had a real teacher too. And I know that you're doing the best that you can. There's some really great progress. And just kind of have the faith. You are not doing busy work at all. You are exactly on pace with where any other Algebra 2 student would be. So, have patience with yourself. I am going to offer office hours if that is helpful and enough people can attend them. So on Wednesday and Thursday's lesson for this week, just put the time and day that you can go or if you want to go. But in a couple sections, you're rocking it. In a couple sections, there are a lot of blank and missing slides. So please make sure that you're doing it to the best of your ability, reaching out to me, watching the videos. And again, I know it's not perfect. I know having a teacher in the classroom would be the best, right? But we're doing what we can with what we have right now. All right. So that said, let's get into the lesson that you did on multiplicity. All right, lesson 1.5. Okay, so all right, so there are some noticings and wonderings. The big takeaway here is that I have a squared, right? So if I were to write this out, let me see if I can actually write this on here. That would be x, let's see if I remember, I have a horrible memory, x minus 3 times x minus 3. Okay, so this squared means x minus 3 is being multiplied by itself, and that would give you a quadratic, right? If I were to actually multiply this out and put it in standard form, it would start with an x squared. Okay, now in this one, maybe I'll try and put it down here so that it doesn't block it. But here I have the factor of x plus 1. And then I have the factor of x minus 3 to the second power. So this x minus 3 is going to be multiplied by itself twice. Right? So even though, let's see, oh yeah, I can do that. Okay, cool. All right, so even though it looks like, oh, okay, I see a square here, right? Let's get rid of that. Okay, even though I see to the second power here, it's really a cubic or an x to the third power, third degree polynomial, because I've got x times x times x. Again, if you were to do this all out in standard form, you would get a function that started with y equals x to the third. All right, and that's why it gives you this shape. If it's positive, right? If I had a positive in front of usually the first factor, then you're always going to get this shape where you start down low, you go up, you dip down, and you go up. Okay, so that's like a common cubic shape. Here, this is a common parabola. If I were to have put a negative here, the parabola would just go downwards. Right? And so let me not do that because that's not actually what this graph is. And if I were to put a negative here, that would have the effect of still having the same shape, but instead of starting down here, I'd be starting up. Right? And if you're thinking, that's just a lot to remember, remember you can always go to Desmos, all right, and actually just graph it. I did have a question about multiplicity and the hills, like how it kind of goes like up and then down and then up, like how many hills that has. And multiplicity and the number of hills don't really have a connection. All right. So don't think in terms of like the multiplicity of it and the hills. And if you forget what multiplicity is, we're going to go over that. Just know for right now, there's no real connection there. Okay. What does have a connection is if it is an x to the third, right, a cubic function, you're going to start, if you start down here, you're going to end the opposite direction or up, okay? And here, if I start up here and it's a quadratic, I know I'm going to end up, all right? So that's true for any function that has an even degree polynomial, like the highest one is even, whether it's x to the fourth, x to the 10th, it is always going to start, right, in this case up, and end in the same direction, okay? And if it's an odd, like x to the third, x to the fifth, x to the ninth, whatever, the end function, starting in one place and ending in the other, okay? So that's the real connection between the degree polynomial and the end function. All right. The multiplicity just tells you whether to bounce off of the x or to go straight through it. Okay. And actually, let me just, should I do this? All right. Because I was looking this up to see if I could give you an example. But see how this is x to the fourth, right? This is a fourth degree polynomial. Let's see. I think maybe you couldn't see that because of the way that I'm filming this. So actually, I'm not going to do that. But I might put it in your notes in the future just so that I can answer that question a little bit better. Okay. All right. So sorry about that. Let's keep going. And I'll figure out how I can switch screens and you can still see me. Okay. Anyways, forget it. Moving on. What is a multiplicity? A multiplicity is the number of times a factor appears. The number of times a factor appears. Okay? So if I were to go back here to my last slide, okay, so this factor of x minus 3 has a multiplicity of 2. Okay? Anytime you have an even number multiplicity, that means it's going to bounce off the x. Okay, so if you see here, I'm going down. Oh, my x-intercept is a positive 3. We should know that, right? Because I see x minus 3 repeated an even number of times, even number means bounce and go the other direction, okay? When, again, here I have x plus 1 as a factor, so there's my 0 of negative 1. And here, again, I have x minus 3. It's repeated twice. It's got a multiplicity of 2. I see x minus 3 twice. So I've got, all right, negative 1. And then as I come here, remember, a multiplicity that's even means I'm going to bounce and go the other direction. Okay. In this one, let's move this down here. You might not be able to see it, but this is x minus 3 to the third power. It's an odd number that I'm multiplying this factor by itself. So I've got x minus 3. Okay, and I'm doing this a third time. So because it is being repeated thrice, right, 3 times, that means that at x being 3, right, the 0, x would have to be 3. That means that as this cubic function goes up, it actually goes through that 0, right? As opposed to here where it bounced off of that 0, right? So again, when the multiplicity is, I was trying to highlight that. Okay, when the multiplicity is an even number like 2, right? I see this repeated twice, bounce, right? Again, I see this repeated twice at x minus 3. So at that 0, I bounce, right? Here, I see x minus 3 repeated 3 times. Anytime it's an odd multiplicity, that means it's going to go through that x-intercept. All right. So that's kind of a preview for the next stuff. So this basically is just saying exactly what I was telling you. When the factor is repeated an even number of times, like twice, then I know that at that factor, so let me just try and draw this and sketch it out. So here, okay. I know that my y-intercept is going to be at a positive 9. Okay, so let's say 9 is here. And then I see x plus 3, so my 0, what would this have to be so that when I add 3, I get 0? Okay, hopefully you said negative 3, so we're going to put like negative 3 here. Okay, so I'm guessing the parabola kind of goes like this. All right, I don't really know. I just care about, did I get the y-intercept in the right place and did I get the x? All the other stuff, you're just sketching, right? Okay, so I've got x plus 3 repeated, again, an even number of times. So when I have my quadratic, right, it's a quadratic, it's second degree, right? It's going to be something like I reach this x-intercept and I bounce the other direction. Oops. Okay, pretend for me that I actually just went through 9. I should be going through 9 here. Okay, so again, is this sketch perfect? Laughably not so, but I'm showing that it bounces in the right direction. Again, remember, if there was a negative here, then I would actually be going down with my u. All right, so you should know the shape. You should know the end function, right? That starts up, ends up. And again, let me erase that because that's not actually true, right? So because this is positive right here, that is why I have an upwards U shape. Okay. Right, and these notes are similar to what I was just telling you. If it is repeated 3 times, right? And it could be 3, any, like any odd number. It could have been repeated 5 times, whatever. Okay. It would say, I would say, oh, this has a multiplicity of 3. The factor x minus 1 has a multiplicity of 3. Okay. And if I wanted to actually sketch that, right? So here is my graph. I know that my y-intercept is at -1, -1. And I know that cubic functions kind of have this shape, okay? Again, is it perfect? No. But my end function, it starts down here, ends up here, okay? And there's no negative in front of it, so I know that it's going to be like starting down here, ending up, all right? All right, so I know that it goes through here, and this 0 would have to be at +1, right? Because 1 minus 1 would make that a 0. Okay, so here's 1. All right, so I'm going to be coming up here. I know it goes through the y-axis at -1. I'm going to kind of squiggle over, and there we go. Okay. And again, however many hills it has, don't worry about that right now. It has nothing to do with the multiplicity. The multiplicity, remember, an odd multiplicity means at the 0, the function goes straight through it, as opposed to bouncing and going the other direction. Okay. All right, so hopefully that makes a little bit of sense. I will explain the bumps, right? How many bumps you have later in the course. And I would have tonight, except, technology. What can you do? All right. Just know it's not an important part of this. The important part is the end function, the shape of it, understanding the multiplicity, that if it repeats an odd number of times, it goes straight through versus an even number of times bounces. Yeah. So there are things you do need to know. How many bumps it has is not one of them. Okay. A lot of people said that they had trouble predicting. There are a couple slides that are similar, so I'm going to do this one, and then I'm going to move on because there were some slides that were specifically requested. Okay, so here I've got x plus 2, so my 0 here would have to be -2. Let's see if I can, yeah. So here would be -2. Here, the x would have to be 2, because 2 minus 2 is 0. Okay. Here, the x would be +8, because 8 minus 8 is also 0. Okay. Now, I know that I've got x times x times x. if you wanted to, you could actually multiply the binomials and then whatever you get here, multiply that by the x minus 8. Get fancy with it. But you should be able to know that when you have this x times this other x times this x, you would end up with an x to the third function. And again, remember, unless you've got a negative sign in front of this first parentheses, your function should look something like this. Okay, starts at the bottom, ends at the top. All right, so I'm going to start here. I'm going to go through. I'm not quite sure where the y-intercept is here. Gotta love standard form. I'm going to go back down. And again, this is just repeated once or not repeated at all. All right, and then I'm going to go back up, hit this one. And that is my sketch. Okay, the end functions match. I went through the correct zeros and I'm good. All right. So again, I'm going to write it all on this one. So the degree is 3, right? It's a 3-degree polynomial. Let me actually write that. Third degree. Okay. The zeros are for x equals -2, 2, and 8. Okay. And the end behavior, behavior is that, okay, I'm going to use just like user-friendly language here. There is notation that we're going to get through, but on your test, if you can just say that it starts down and ends up, that's fine. Okay. And ends up. Okay. So yeah, the end behavior is just on either end of it, right? So we're saying start, but you know, on either end, what does it look like? Okay, so this is similar. And just remember, actually, I will do this. I always say I won't do all of them, but then I'm like, I want to do all of them. Okay, so I'm noticing that this is now negative. And if I were to write all of my factors out, I would have the negative, the x plus 2. Okay, right? I'm just rewriting these. And then x minus 2 is squared, right? So if you're sensing a multiplicity, you are absolutely right. So x minus 2 is being multiplied by itself 2 times. All right, so if it's an even number, and I'm actually going to write that in here, right? I'm going to say x minus 2, well, let's say the factor x minus 2 has a multiplicity of 2. Let me write out 2. All right, anytime it is even, it will bounce off the x, okay? Bounce. The fact that this is negative means that normally I have a cubic function that goes like this, but because it's negative, it changes around. So instead of starting downwards, I'm actually going to start upwards, right? And end down. So this is like a y equals x, oops, sorry, negative x to the third, versus this one is just your generic, positive x to the third. Okay. All right. So here again, it is a cubic, right? X times x would give you an x to the third, right? So the degree here is 3. So it's a 3rd degree polynomial. Okay, I'm not going to finish the rest just for time and because we did a similar thing in the last one. So again, your zeros will be at -2 and at +2. All right. So remember, it's negative. So I'm starting up here. This -2 doesn't have a multiplicity. I'm going to go straight through it, right? I only see it once here, right? -2 would be here because -2 + 2 is 0. And then here at +2, where my 0 is +2, I've got an even numbered multiplicity. It repeats twice. So that means I'm going to go here, I'm going to bounce and go the other direction. Okay. All right, so it's a third degree polynomial, and that's your sketch. Oh, let's see this one. Can I resist? All right, I'm not going to write everything down here, but I am going to look at it, okay? So I have x + 2 twice, right? So that's a multiplicity of 2. So let me just put my 0 should be at -6 and -2, okay? This is cubic, right? Because I've got x times x, but remember, I'm multiplying by another x because this is squared, right? So it should be x times x times x, or x third. And it's positive, so I'm starting down here. I'm going through the -6, and then at -2, remember it's got an even numbered time it repeats, an even number multiplicity. So it's gonna bounce and go the other direction. Okay. Here, remember, anytime it's odd, anytime it has an odd number of repeats, it goes through the x-axis. And if you think about it, if it just happens once, the exponent out here is 1, which is an odd number. So anytime it happens and it's an odd number, it goes through the x-axis. Anytime it repeats itself an even number time, it bounces and goes the other direction. Okay. All right, I will let you do that one since I did not get a question on it. But I did on 15 and 16. Okay. Oh, so given the graph on the left, can you pick out the x and y intercepts? Great question. All right, so this is the y-axis, right? And this is the x-axis. Let's start there. All right, the x-intercept is just where it crosses the x-axis. So this point, remember, you always write your x and then your y if you're doing the points. So the x value here is 4. And because it didn't go up or down, right? It didn't, the y-axis goes up and down. It just 4, 0. So 4, 0. Oops, that is not a 4. All right, 4, 0. All right, I'm obviously having issues. Thank you. Okay. All right, and then here, the y-intercept is same thing. So I look at the y-axis, and the line intercepts it right here at -2. So now the y value is that -2, and x is 0. So at the intercepts, if it's an x-axis, you're going to get a value for x. Y value is always 0. At the y-intercept, you've got a y number, but the x is always going to be 0. Okay, so again, it's at -2. So this time the x is a 0 and the y is a -2. Okay, cool. So let's go to the next one, 15. Oh, so same thing. So here, the x-intercept, oh, I see it. It's right here. So that means the x value is -5. The y value is 0. And again, remember, if it's a y-intercept, I know already without even looking at it that my x value is going to be 0. And then let's see. So it's right smack in the middle of -2 and -3. So that would be -2.5. Okay, let's see what else we got here. All right, sketch the graph of the second degree polynomial. So it should look, I've got second degree, right? So it should look something like this. Okay. So again, because it's positive, there's no negative sign here. And let me actually erase that. Because there's no negative sign, it always faces upwards. If there were a negative sign in front of the x squared, it would be facing downwards. Okay, so that's the main thing. Are you getting the end function correct? Are you getting the zeros correct? Okay. I also had a question on, well, this one described the graph. So you should mention that it starts up, ends up. So in the same direction, begins and ends in the same direction, and it's got an x-intercept of 0. Okay, we've gone through the third, right? X to the third. So again, we know it starts down here, it does something here, and it goes up. Okay, so yeah, you should really talk about its end function. It starts down here, ends up here, x-intercept of 0. It's actually got a y-intercept of 0 too, right? It's where it hits both of the axes. All right, so a fourth degree polynomial. Again, you could have a fourth degree polynomial that has no bumps in it, right? You could have also a couple direction changes. So I don't care about the bumps right now, right? So you can kind of just play around with that. So again, a fourth degree is similar to a second degree, where if it starts up, right, it should end up, right? Maybe there's a couple ups and downs here. Who knows? Okay, we'll get to that. But the end functions are really important in sketching this fourth degree polynomial. You also sometimes get, something like this where it just kind of flattens out a little bit more than like a normal parabola. So it can have different amounts of bumps, or maybe not, not so many other than turning around. Okay, again, important part is the end functions and any intercepts that you know of. Okay, so these are graphs of fourth degree polynomials. See this one? It almost looks like a quadratic, right? So there are different numbers of bumps, of waves, whatever, but you should notice they all have end functions that are similar to a quadratic. Starts down here, ends down here. Starts up here, ends up here. Okay, for all of them. Oh, and I think, yeah, someone did want to go over 22. Okay, so I hope that that was the question on 22. What do they have in common? Their end functions are all the same, right? Or, either they start and end in the same place is what I'm trying to say. Obviously some of them start down and end down, others start up and end up, but they all the wording that was used in the last one is like as x gets greater and greater negative, right? You could always make a table and say, all right, at negative 100, just a really big negative x number. So if I'm going this way, my y value is starting down in the negative. My y value is really, really negative, right? And then as x values get super positive, right? I'm just going to pick a big positive x value, right? So as I keep going further and further in this direction, the y values get bigger and bigger in the negative direction, okay? So I like making this table. It makes that wording sound a little bit better. But again, that wording will not, we're going to try and simplify the wording for your assessment. Okay. Your first assessment is next Wednesday and Thursday. Again, the next lesson that you will have in Algebra 2, I put a slide on there to ask if you would like office hours and when you're available to come. So hopefully you have some time in your schedule, and that is something that you'd like to do. Because I know, a lot of you are feeling like, hey, I just need a little bit more time, having someone check my work or whatnot. So please let me know, and then we will kind of take it from there. All right, so that is all I got today. I will see you later.